We have 4 objectives in this section. Find the derivative of the function using the product rule. Find the derivative of the function using the quotient rule. Find the derivative of the trigonometric function. Find a higher order derivative of a function. You learn that the derivative of the sum of two functions is simply the sum of derivative. The rules for the derivative of the product and quotient of two functions are not as simple. The product of two differentiable functions, f and g, is itself differentiable. Moreover, the derivative of fg is the first function times the derivative of the second, plus the second function times the derivative of the first. So, differentiate the fx gx with respect to x is equal to fx multiply g prime x plus gx multiply f prime x. The product rule can be extended to cover products involving more than two factors. For example, if f, g, and h are differentiable functions of x, then differentiate the fx, gx, hx with respect to x is given by this formula. Meaning that first we differentiate the fx function and then multiply the gx and hx plus we differentiate the second function. So we have g prime x multiply fx multiply hx plus we differentiate the third function, which is hx. So we have h prime x multiply fx multiply gx. Look at the example below. Y equal to x squared sine x cosine x. There are three functions here. So we differentiate the first function x squared by using the power rule. So we have 2x multiply the second function and the third function plus we differentiate the second function, which is sine x. So we differentiate sine x, we have cosine x, and multiply the first and the third function plus we differentiate the third function. So we differentiate the cosine x, we have negative sine x, and multiply the first function and second function. And then we simplify our answer. The derivative of a product of two functions is not given by the product of the derivative of two functions. Look at the first example. Find the derivative of hx equal to 3x minus 2x squared multiply 5 plus 4x. So for this case, we do not need to expand. We can use product rule. So h prime x equal to, we differentiate the second function. So we write differentiate the second function with respect to x, multiply the first function, plus we differentiate the first function, multiply the second function. And in the previous section, you learned when we differentiate the 5 plus 4x, this is in the sum form. So we can use the sum rule. So we straight away to differentiate the 5 and the 4x. So we have 4. Because we differentiate the 5, it's equal to 0. And same for this part. 3x is a constant multiple rule, and minus negative 2x squared also is a constant multiple rule. And after we obtain, and we can simplify the answer. For the quotient rule, the quotient f over g of two differentiable functions f and g is itself differentiable at all values of x for which gx not equal to 0. Moreover, the derivative of f over g is given by the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, or divided by the square of the denominator. Look at this formula. Be careful of the formula. The common mistake made by students when they perform the quotient rule, differentiate the fx over gx with respect to x. We should differentiate the first function f prime x multiply the second function. The first function is fx. The second function is gx. Look at the formula. It's not differentiate the second function and then multiply the first function minus differentiate the first function multiply the second function and divided by gx squared. This is a wrong formula. Find the derivative of y equal to 5x minus 2 over x squared plus 1. This is a rational function, so we use quotient rule. Remember, for the quotient rule, we differentiate the first function. This is a first derivative of the first function and multiply by the second function minus. We differentiate the second function multiplied by the first function divided by second function square. We simplify our answer. And you get the simplest answer. Knowing the derivative of the sine and cosine functions in previous section, you can use the quotient rule to find the derivative of the four remaining trigonometric functions. Differentiate the tangent x with respect to x is equal to secant square x. And these four derivatives of trigonometric functions can be obtained by using the quotient rule. Look at this example. Y equal to x minus tangent x. Since the quotient is in sum and different form, so we use sum and different rule, meaning that straight away to differentiate for the first term and then and then second term. So we differentiate the x, we use power rule. Do you still remember? So we have 1. And we differentiate the tangent x, we have secant square x. And for b, y equal to x multiply secant x. So the main function is in the product form. So we use product rule. We differentiate the second function multiplied by the first function plus we differentiate the first function multiply the second function, and then we simplify. The summary below shows that much of the work in obtaining a simplified form of a derivative occurs after differentiating. Note that two characteristics of a simplified form are the absence of negative exponents and the company of like terms. Look at the comparison between these two. Before simplify and after simplify. Just as you can obtain a velocity function by differentiating a position function, you can obtain an acceleration function by differentiating a velocity function. To get the acceleration function, you need to differentiate a velocity function. Another way of looking at this is that you can obtain an acceleration function by differentiating a position function twice. Look at the sequence. First, we have position function, and we differentiate. We have velocity function, and we differentiate again. So we have acceleration function, or equivalent. The notation is s prime by t. The function at is the second derivative of st and is denoted by s prime by t. The second derivative is an example of a higher order derivative. You can define derivative of any positive integer order. For example, the third derivative is the derivative of the second derivative. The notation of higher order derivative are listed here. For example, we can use y prime or f prime x dy dx. Differentiate the fx with respect to x, or we can use the capital letter of D represent differentiate the y with respect to x. Look at this example. Because the moon has no atmosphere, a falling object on the moon encounters no air resistance. In 1971, astronaut David Scott demonstrated that a feather and a hammer fall at the same rate on the moon. The position function for each of that falling object is given by this function, where st is the height in meters and t is the time in seconds. What is the ratio? Of the Earth's gravitational force to the moon? To find the acceleration, differentiate the position function twice. Now we obtain the acceleration function. So the acceleration due to gravity on the moon is negative 1.62 meters per second per second. Because the acceleration due to gravity on Earth is negative 9.8 meters per second, so the ratio of Earth gravitational force to the moon is given by negative 9.8 over negative 9.62. So the answer is around 6.